Hi students, welcome back to Max Video Classes. In this video, I'm going to explain the remaining sums in exercise 6.3. Okay, so everyone open the textbooks and your running notes. And let's see the fifth one. For each of the following numbers, find the smallest whole number by which it should be multiplied so as to get a perfect square number. Also, find the square root of find the square root of the square number so obtained. Here some numbers are given. Okay, it is very clear that given numbers are non-perfect square numbers, but when you are multiply these numbers by a whole number, then you get a perfect square number. So you find that smallest whole number, that means which whole number you multiply that given number, you get a perfect square number, and also find the square root of that numbers. Okay, so for finding that smallest whole number, here we have only one way, that is finding the prime factorization of the given number. For example, let us take the first number. The first given number is, yes, it's 252. Find out the prime factorization of this 252. Okay, so this 252 is divisible by 2. How many times? 126 times. And this 126 again divisible by 2. How many times? 63 times. And 63 is divisible by 3. How many times? 21 times. And this 3 is divisible by, this 21 is divisible by 7. How many times? It's 7 times. So the prime factorization of the given number is 2 into 2 into 3 into 3 into 7. Okay, so what are the prime factors of this number? Here we have 3 prime factors. What are the 3 prime factors? 2, 3 and 7. Okay, so when you observe these prime factors, as 2 has a pair and 3 has a pair, but 7 has no pair. So when you are grouping these prime factors, in pairs, yes, 2 has a pair, 3 has a pair, but 7 has no pair. So when you multiply this given number by 7, yes, 7 has also, when you multiply this number by 7, yes, that 7 has also have a pair. Okay, so what is the smallest whole number to multiply this number to get a perfect square number? It's 7 only. Okay, here we clearly present that. Here, so in this prime factorization, prime factor 7 has no pair. So that means therefore 252 must be multiplied by 7 to make it a perfect square number. To make it a perfect square number. Okay, so therefore, so when you multiply that given number by 7, that means 252 into 7. Here the product is 252 into 7. 7 2 is 14, 7 5 is 35, 36. 36 and 7 2 is 14 plus 3 17. So it's 1764. And also we find the square root of this number. So square root of 1764, it is equal to, already we find the prime factorization of 252. What is its prime factorization? It's 2 into 2 into 3 into 3 into 7, and we get this 1764 by multiplying this 252 by 7. So you add this prime factor to this product. So this is the prime factorization of 1764. And in this prime factorization, every factor has a pair. So let us take one factor from that pair. 2 into 3 into 7. Here the product is 2, 3, 6, 6 sevens 42. So 42 is the square root of 1764. So like this you do the remaining all. Okay, let's come to the next one, sixth one. For each of the following numbers, find the smallest whole number by which it should be divided so as to get a perfect square. Also find the square root of square number so obtained. Okay, so in the fifth one we are finding the smallest whole number, which one we multiply to get a perfect square number. Now we divide. For each of the following numbers, find the smallest whole number by which it should be divided so as to get a perfect square numbers. That means they are not perfect square numbers, so but when you divide these numbers by a smallest whole number, then you get a perfect square number. So what is that smallest whole number? We find it. Okay, first write down the given number. So for this also the only solution is finding its prime factorization. So that given number is 252. So its prime factorization already we did. In the fifth one already we did. So what is its prime factorization? 2 into 2 into 3 into 3 into 7. Okay, so what are the prime factors of this 252? Yes, there are 3 prime factors, 2, 3, 7, but 7 has no pair. So when you divide this total number by 7, yes, that 7 is cancelled. So what are the prime factors in the result? Yes, we have only 2 prime factors. What are the 2 and 3, and they have pairs. So what is the smallest number that we divide to get a perfect square number? Yes, that number is 7. Why? Because 7 has no pair in this prime factorization. Here we present that clearly. Okay, so here prime factor 7 has no pair. So therefore this 252 must be divided by 7 to make it a perfect square. Okay, and when you divide that given number by 7, that means 252 divided by 7. Let's do this division. So first how many times? 3 times 21 and 42. Next how many times? 6 times 42, 0. So 252 divided by 7, it is equal to 36, and we find that square root of 36 also. So square root of 36, it is equal to 6. 36 na. So square root of 36 is equal to 6. Okay, let's we take one more. Fifth one, 2800. Okay, find out the prime factorization of this 2800. So it's divisible by 2, 1400. Again it's divisible by 2, 700 times. Again it's divisible by 2, 350 times. Again it's divisible by 2. How many times? 175 times. And this 175 is divisible by 5, 35 times. And this 35 is divisible by 5, 7 times. So its prime factorization is 2 into 2 into 2 into 2 into 5 into 5 into 7. Okay, so what are the prime factors of this number? 2, 5 and 7. And when you observe that first prime factor 2 has a pair. Yes, 2 is repeated 4 times. So when you take the pairs, S 2, 2. Here we have two pairs, and 5 has a pair, but 7 has no pair. So that's why when you are divide this total number, this 2800 by 7, yes, we get a perfect square number. Here prime factor 7 has no pair. Therefore, this 2800 must be divided by 7 to make it a perfect square. To make it a perfect square. Okay, and when you divide this 2800 by 7, here the quotient is 400. Why? Because 7 4 is 28 na. So 2800 divided by 7 is equal to 400, and when you find the square root of this 400, it is equal to square root of 400. Prime factorization is 2 into 2 into 2 into 2 into 5 into 5. Just in the prime factorization of 2800, just you remove this 7. Why? Because we are divide that given number by 7. So just you remove this. So 2 into 2 into 2 into 5 into 5. Let us take the pairs. 2 into 2 1 pair, 2 into 2 1 pair, and 5 into 5 1 pair. And let's take 1 factor from each pair. 2 2 5 and multiply them. 2 into 2 into 5, it is equal to 20. So 20 is the square root of 400. Okay, so in the same way do the remaining all. Let's come to the next one. The student of class 8 of your school donated 2401 rupees in all for Prime Minister National Relief Fund. Each student donated as many rupees as the number of students in the class. Find the number of students in the class. So this is a word problem. Observe it carefully. The students of class 8 of a school donate 2401 rupees in all for Prime Minister National Relief Fund, and each student donated as many rupees as the number of students in the class. So find the number of students in the class. Here what are the unknowns? As the number of students in the class and each student donated how much money. It is equal to the number of students in the class. So here the unknown is only the number of students. Generally we take that unknown as X, Y, Z. We can use any letter. Let's we take that quantity as X. Let the number of students be number of students be X, then each student donates how much money? It is equal to the number of students in the class. So therefore each student donates how much money? It is equal to number of students in the class. How many number of students in the class? There are X students. So each student donates X rupees. Okay. From these two quantities, so the total number of students donated how much money from these two quantities? Therefore, donated money is equal to, how to find it? Yes, there are X students in the class and each student donates X rupees. So how much money they donated? X into X, number of students into money donated by each student, that is x, it is equal to x square. But according to the question, this donated money is equal to it's 2401 rupees, and this 2401 rupees and this x square presents the same quantity, so that's why we equating these two values. So x square is equal to 2401. That means this 2401 is the square of one particular natural number. We find it. So this 2401 is the square of which natural number? For finding it, let's find out the prime factorization of this 2401. It's divisible by 7. How many times? 343 times. And again this 343 is divisible by 7. How many times? 49. And 49 is divisible by 7. How many times? 7 times. So prime factorization is 7 into 7 into 7 into 7. Okay, means it's 7 into 7 whole square. Or we can write this answer like this also. So here x square is equal to 2401. That means this 2401 is the square of one natural number. This 2401 is the square of one natural number. So that natural number is square root of 2401. You can treat like this also, no problem. Okay, that means simply transposing the square to right side. When you transpose square to right side, it changes to square root. Why? Because square root is the inverse of square. And when you find the square root of this 2401, the prime factorization is it's 7 into 7 into 7 into 7. Let us take one factor from each pair. Here how many pairs are there? There are 2 pairs. So let us take one factor from each pair. 7 into 7. So it is equal to 49. So x is equal to 49. What is x? The number of students in the class is x. That quantity is equal to 49. Hence the number of students is the number of students is 49. Okay, so this is the 7th one. Let's come to the next one. 2025 plants are to be planted in a garden in such a way that each row contains as many plants as the number of rows. Find the number of rows and the number of plants in each row. Okay, this is also a word problem. Just observe it carefully. 2025 plants are to be planted in a garden in such a way that each row contains as many plants as the number of rows. So find the number of rows and the number of plants in each row. Here what are the two unknowns? Yes, the number of rows and the number of plants in each row. But these two unknown quantities are related to each other. Each row contains as many plants as the number of rows. So which quantity we are taken as x? Yes, the number of rows of planted, that means the number of rows that can be planted, be x. Okay, let the number of rows be x. Then according to the question, each row how many plants are there? Yes, there are x plants. So each row contains x number of plants. Okay, so in that garden totally how many plants are there? Total number of plants in garden. x plants are arranged in x rows. Okay, so in each row, if you are take x plants arranged in x rows, so how many plants are there? By multiplying these two, as x into x, it is equal to x square. But according to the question, the total number of plants in the garden is 2025. So this x square is equal to 2025. That means this 2025 is the square of one particular number. That means that number is the square root of this 2025. That means here I transpose this square to right side, it changes to square root, it becomes to square root. Okay, now find out the prime factorization of this 2025. It's divisible by 5. How many times? 405 times. Again, it's divisible by 5. How many times? 81 times. And it's divisible by 3. 27 times divisible by 3, 9 times divisible by 3, 3 times. So it is equal to square root of, when you arrange that prime factors in a proper order, it's 3 into 3 into 3 into 3 into 5 into 5. Okay, so let us find out the pairs. Here totally we have 3 pairs. So let us take one factor from each pair. So 3 into 3 into 5. So it is equal to 3, 3 is 9, 9 5 is 45. That means this 2025 is the square of this 45. So how many rows are there? There are 45 rows, and in each row how many plants are there? Yes, there are 45 plants in each row. Okay, so this is the 8th one, and come to the next one. Find the smallest square number that is divisible by each of the numbers 4, 9 and 10. Find the smallest square number. You find a perfect square number, smallest perfect square number. What is that? That is divisible by each of the following numbers 4, 9 and 10. Okay, first you forget this smallest square number. First you find the number that is divisible by each of the given numbers. So what is that number? How to find that number which divisible by each of these numbers 4, 9 and 10? How to find it? By finding their LCM. Okay, so first find the LCM of the given number. So LCM of 4, 9 and 10. 4, 9, 10. So 4 and 10 both are divisible by 2. So 2 times, 5 times, and no one is divisible by any prime number. So find that 2 into 2 4, 4 into 5 20, into 9 180. So LCM of 4, 9 and 10 is 180. That means this 180 is divisible by every number 4, 9 and 10. And already we know one property. What is that? What is that property? So when you find the LCM of a group of numbers, the multiples of the LCM also divisible by that same group of numbers. That means here this 180 is divisible by 4, 9, 10. Why? Because this 180 is the LCM of these numbers. In case when you find the multiples of 180, yes, 180, the second multiple is 360. It is also divisible by 4, 9 and 12. Sorry, 4, 9 and 10. And what is the third multiple? It's 540. This is also divisible by 4, 9 and 10. Is it clear? That means when you find the multiples of LCM of a group of numbers, that multiples are also divisible by that group of numbers. So like that, if you are continue to find the multiples of this 180, at one particular place we find a smallest square number. We find x square number, find it. So to find that, we have an alternative. What is that? Finding its prime factorization. So prime factorization of 180 is, it's 2 into 2 into 3 into 3 into 5. By observing this division, we can easily write it. This 180 is the product of these four numbers, na? Out of these four numbers, 2 is a prime number, 2 is a prime number, 5 is a prime number, and we can express this 9 as 3 into 3. It's very easy, na? Okay, and in this prime factorization, which factor has no pair? 5. So multiply that given number, that means this 180 by 5. Here we clearly present that here the prime factor, here the prime factor 5 has no pair. So 180 must be multiplied by 5 to make it a perfect square. So therefore 180 into 5, it is equal to 900. And you remember this 900 is the multiple of 180. Why? Because we get this 900 by multiplying a number by 180. So 180 into 5, it is equal to 900. And this 900 is the smallest square number which is divisible by 4, 9 and 10. Hence 900 is the smallest. 900 is the smallest perfect square number which is divisible by 4, 9 and 10. Okay, so this is the ninth one, and let's come to the last but not least. Find the smallest square number that is divisible by each of the numbers 8, 15 and 20. Same model. You find the smallest square number that is divisible by each of the numbers 8, 15 and 20. So what is the first step? We find the LCM of the given numbers. Okay, and prime factorization of this LCM, and identify which factor has no pair. Multiply that LCM by that number, then you get the smallest square number that is divisible by each of the numbers 8, 15 and 20. Okay, let us do your work. This is exercise 6.3. Remaining we will continue in the next video. So thank you for watching. Bye.